Kia ora, and welcome to a lesson on Cambridge Mathematics P2 and P3 modulus function graphs. Okay, to plot a modulus function graph, we first need to understand the most basic graph there is, which is the y equals x graph, but as a modulus function. So, as you should already know, the modulus function just takes any negative value of x in this case and makes it positive. So if I think about my standard y equals x graph, it will look something like this. A straight line going through 0 on a diagonal like that. But what modulus does is it takes every negative x input along here and gives the output as positive. So what is going to happen is when it gets to the point where x becomes negative, it's going to flip it positive. So it creates this sort of image where it's being reflected in the x-axis on the negative side of the x values. Okay, so how will this look with a more complex one, such as y equals modulus half x minus 1? So let's think of our standard graph, y equals a half x minus 1. So that would normally go through the y-axis at minus 1. Because it's a half x, that means for every one long it's going to go half up, so it's going to go one long half up, one long half up to cross the x-axis at 2. So our normal graph, y equals a half x minus 1, would look something like that. Okay? But as the values for y will never become negative in this case, because the graph, when it does start to produce negative values down here, it will become positive values. So what our graph will actually look like is something like that, where it will cross the y-axis now at positive 1. So this is the y equals modulus half x minus 1. So every time it hits that x-axis, it's reflecting up in this case. Let's have a look at another example. Y equals 3x plus 6. So y equals 3x plus 6, the standard graph for it would cross the y-axis at 6 and the x-axis at minus 2, and it would look a little something like that. Bad drawing, let's try that again. A little something like that. Okay, again, because this is all modulus, the 3x plus 6 is all modulus, it's only ever going to return positive y values. So when it gets to the point where it would go negative y values, it's just going to flip up. Still going to cross at 6, but then you're going to get a symmetrical graph in the x-axis. Okay, so let's have a look at another one, slightly more difficult this time. This is y equals modulus x plus 2 minus 1. So to sketch this graph, the first thing I'm going to think about is what the graph y equals modulus x plus 2 would look like. So y equals modulus x plus 2 would be a graph which goes through 2. It would go to minus 2, but this time I'm not going to worry about drawing what y equals x plus 2 would look like. I'm just going to draw the modulus version. So this would look something like that. Okay, that is y equals modulus x plus 2. So y equals modulus x plus 2 minus 1 is the same as y equals modulus x plus 2, but then all of the values are going to be shifted down 1. So this time it's not going to just bounce back when it hits the x-axis. It's actually going to bounce back when it gets to -1 in the y values. So it's going to look something like that. Okay. The intercept point here would be 1 because it's been reduced by 1. The turning point, the -2, the vertex at -2, 0 will now become -2, -1. And then it will cross back over here at -3 and cross over here at -1. Okay, so that's just a quick sketch of this graph. Y equals modulus x plus 2 minus 1. So like I say, same as the y equals modulus x plus 2 graph, just then shift down 1. Okay, so we're getting into the realms where we're wanting to start thinking about how do our numbers affect the graph. Okay, so we're going to talk about how we can find the vertex. So finding the vertex of a modulus graph is fairly straightforward, just with a bit of thinking. So the way I like to think about it is this part here is really the important part about where that graph is going to flip, because there's going to be a point where this gets as small as it can before getting bigger again, because it will never go past 0. So the smallest value that could ever be inside a modulus, or produced by modulus, is 0. So that's really important for finding the vertex point, because that is going to tell us what the smallest value of this could be, 0, plus our c value will be the smallest value of y. Okay, so all you have to do is say that ax plus b is equal to 0. So therefore, ax equals minus b. So the x ordinate of the turning point is minus b over a. Okay, and then that graph is shifted from the x-axis by the value c. Okay, because if this is 0, c tells you how high or low it's going to be. So the basic form of this graph is something like this, with a turning point at minus b over a, c. Okay, this will allow you to quickly find the turning point, so you can do a quick sketch of a graph. Obviously, here will still be this point here will be plus or minus b plus c, depending on whether this is negative or not. So if the b is negative, you take the negative of the negative and make it positive. In fact, probably a better way of saying that would be to say it would be modulus b plus c. Okay, hopefully you understood all that, so you can quickly sketch some modulus graphs yourselves now. Good luck, and I'll speak to you again soon.